So today it's going to be Scott and I, and we're going to talk about, how do we tune our content? How can we get rid of lousy detections, or can we make lousy detections better? All right. So last week I was here, or last week, excuse me, 2 weeks ago. I was able to present on how we're doing machine learning and how to use that for hunting on detections and alerts that are generated. And just a reminder, I'm based out of Hartford, principal data scientist here at Anvilogic, detected your malware, helped you with your managed security services at Symantec, sent you Gmail at Google, and did my PhD in computer science at Stony Brook. And on the line today, we got my coworker, my collaborator, my partner in crime here, Scott Rodgers.
Hey, yeah, so Scott Rodgers. I'm based out of Charlotte, North Carolina, and I'm a data scientist here at Anvilogic. And before that, I was also a data scientist at a financial services company, TIA, in the cybersecurity space, and been in cybersecurity space for a little while.
Excellent. All right, so let's jump into it. So today, unfortunately, Jade couldn't join us, but you'll enjoy the witty repartee of Scott and I, which we get to do every day, right, as we're on the data science team. So Scott, let me ask you a question. Agree or disagree? Detection engineering is hard.
Yeah, totally agree.
Yeah, I
Totally
think,
agree. One thing I'll say off the bat on that is, new attacks are popping up all the time. It's really difficult to stay on top of them. And one example that I heard recently, a pen tester was hiding his payload inside of a PIM file. So a PIM file, if you don't know, is a key file that's used to authenticate to things. It's encrypted. If you look at it, it just kind of looks like a bunch of garbage, random characters. So most security analysts, looking at that, unless they go ahead and decrypt it, it's going to be a pretty hard one to detect. So that's one example. Yeah.
exactly, right. I mean, and let's talk about like the tools in terms of detecting it, right? So you got your regexes, right? You might do some exact string matching, right? You have your statistics, maybe you do some ranking. I think the other thing too is like if you think about this PEM detection, right? I mean, most likely, you're gonna have to source, basically process command, logs, right? And there's quite a few, right? Any company that you go to, right? I mean, that's going to be a huge volume of logs that you have to run these particular detections to, right? So you have pretty coarse tools running against voluminous log sources, right? And there's endpoint, proxy, cloud, application, right? So all of those, none of them are really like skinny. Even your crowd strikes and things like that, you can get a lot of logs from any of those sources, right? And I think like the big thing is that detection is an ongoing process, right? Like whenever you onboard new tools, right? Let's say you acquire a company, right? Your data is going to change, right? And that could blow up your detection, right? So I think like it is definitely very difficult. And some of the tools that you have, right, can be not quite as flexible as you'd like them to be. So like when I think about how do we manage noisy detections and even maybe reasonably noisy detections, right? So let's talk about, for example, my daughter comes home from school and gets 99 out of 100 on tests. I'd be like, Olivia, you did a great job there, right? But if you had a detection, right, that maybe triggered 1 out of 100 logs, right, and we have log sources that could easily be 10,000, 100,000, a million per day, right, your mountain of detections are going to grow, right? And I think that as a content author, this is very tricky, right? Because Scott, as you were saying, right, we have to keep abreast of all of the latest attack vectors, right? What are the tricks that adversaries are using? Your PEM example is terrific, right? I mean, that's something else that you might have to build content for, right? And that may all of a sudden add to the sort of mountain of detections that can be generated from all the content that you have deployed. So I'd say that when we talk about the SOC analyst, right, who is consuming this sort of alert lake or mountain of detections, right, the tool that they're going to use most likely to whittle it down to a sizable hill of detections, right, is a regex. Or actually, to be honest, right, it's going to be multiple regexes against whatever their SIMs are, right? And that regex can be extremely long. I've seen some interesting ones in my time. And that I think like the difficulty here is that, the content engineer wants to get good detections out the door, but you have constantly changing data sources, you have lots of logs. And for the SOC analyst, right, they're in a position where they're trying to find these attacks, right? They only have so many hours in the day, so they deploy these regexes, they try to search these detections to try to figure out what is most high yield, and that can also be a fraud exercise. So Scott, what are your thoughts on this sort of setup?
Yeah, I mean, circling back to what you started on there, the the landscape's always changing. So maybe you have some good detections, but you know, you like you said, acquire a new tool, a new company, and then your alerts that were working, you know, pretty reasonably well, now are blowing up the sim. And yeah, I don't know if you want to get into alert fatigue, but that's, you know, where this is leading.
Oh, we got to get into it. So tell me, I mean, you worked in the SOC, I was working around the SOC, right? Like, what is this alert fatigue?
Yeah, I mean, alert fatigue is it's exactly what the name says, but you know, you can think about the story, a boy who cried wolf, you know, he cried wolf and there wasn't a wolf, and he cried wolf, there wasn't a wolf. Then eventually there was a wolf and no one listened. I mean, that's essentially alert fatigue. Some other, you know, ways to describe it or think about it. I was actually at a conference recently, and two different pen testers mentioned alert fatigue and trying to hide their activity into noisy alerts to you know, get by analysts. And one pretty interesting example of a pen tester in a social engineering context taking advantage of alert fatigue was they'll spam the MFA, push MFA notifications. So if you get a push notification to your phone, it says, do you want to approve login to, you know, XYZ system? If you hit decline, then you get about 20 more. You think something's broken because it keeps coming up, or it's the middle of the night, and you know, eventually they you know, take advantage of your just autopilot brain, and or maybe even accidentally you just hit approve, and then there you go. So yeah.
Exactly, exactly. You bring up a great point, right? It's just like not only will the pen tester potentially spam, right? The analyst, right? Adversary may spam the analyst. I mean, even by virtue of like in the Windows operating system or any operating system, right? I mean, how many power like you have to as a SOC, right? Every run DLL, PowerShell, probably WScript, right? Even cmd.exe, right? You probably need to monitor it. You need to be able to baseline it. And there's just so many of those logs. And considering that, adversaries use more or less the same APIs, right? They use the same kinds of commands. Yeah, I mean, you can get very, like it just is going to induce fatigue, a sense of complacency, right? If you don't have the tools to really whittle it down, right, to the most manageable things. Now, we talked about regexes, and guess what, right? We also have regexes too, right? So this is a little snippet of a regex that, as we started the Insights project, right, it was imperative, right, for us to like, we have our detections, right, want to try to figure out what do we want to send as a hunting insight? How do we curate the data for our machine learning models, right? Hey, regexes are the way to go. So like, Scott, let's go, one off here, right? Like maintaining regexes. What's the challenge here?
Yeah, I mean, where do you start? You know, challenges, you need to be able to create some good ones that aren't, you know, going to match too much. You don't want to match on things that you might actually want to see. You know, you can see in this example, we got a ton just for, you know, this small example. So that's a few challenges there. It's just, you know, it's going to be really complex, hard to manage. You might have tons of them. And yeah, what about you? Do you have any
Cool.
challenges off the top of your head?
Brittle. Oh, they're brittle, right? Am I the best SQL writer? Am I the best regex writer? No, right? And I think that's the difficulty is like, you'll see something and you try to express it. I spend maybe 2 minutes trying to write that one regex clause, and then I find out that it matches maybe, 0.5% of the clause, right? Like, it can be very challenging to, definitely write those particular regexes. And then the other thing, and and I were talking about this before about like regexes in general, is like, you may have sort of as a SOC analyst, like something that you're particularly interested in seeing, right? And what you might do is you might write the regexes so you kind of get everything out except maybe that kind of attack vector or behavior that you want to see, and you might miss something, right? And again, like you can inadvertently silence things as you're saying that you may actually want to see, because if it's too blunt, right, it just the thing that you want to see maybe occurs 1 in 1,000, 1 in 10,000, 1 in 50,000 logs, right? So I mean, the challenge is that you want to, but on the other hand, right, you need, you have an 8-hour shift, right? You need to get home, right? You can't spend all day looking at millions of logs. So I think it's tricky. So I think what we have done here.
Actually, one last thing, if you don't
Please,
mind, on
please.
that previous one.
Yeah, let's go there.
Just like you're saying, you know, there's you have to focus it on certain things, but you also got to think about what it's designed for. Like, you might be designing it for the perspective of an analyst who needs to look at, logs and determine, what's bad and what's good, or you're designing it for purpose of collecting a lot of logs so that when the analyst finds something, they can go and look into, what's happening on this computer, or maybe like threat hunting, different purpose there. But keeping on top of those is another challenge there for sure on what's the purpose of this regex, how is it being used, and then does the person who's looking at the results of the regex understand its purpose and what it was designed to do.
Exactly, right. And the answer is, particularly in my case, like I'll look at these regexes and sometimes they'll say, I have no idea, right? And then that's research, and then you need to go and try to figure out, like, divine, like what was the purpose of said regex. So, but not again, like, here's what we're doing here at Anvilogic, and we're asking ourselves, like, what if we let the machine write the regexes? So here, what we're talking about specifically, just in terms of what we provide our customer, is it called tuning insights. But the idea that basically, look, we have, rather than saying, here's a pile of alerts, right? And I'm going to write a series of regexes to kind of filter them so that I have a more manageable amount. What we're trying to do is figure out, like, can we write per rule or piece of content, allow the machine to kind of look at, okay, here is it, the logs that are flagged, or the alert detections that are generated based on these logs, right? Can we allow a machine to write allow list filters for each of those rules? So rather than having generic catch-alls, right, which are not bad, but rather what we're thinking about is like per content, right? Can the machine just say, look, for this rule, this is this is an allow list regex, or something that will not detect if that regex matches, right? And I think, like, the advantages of the machine, right, is, first of all, although LLMs aren't good at writing data jokes and stuff like that, right? ML is good at processing large volumes of data, looking for pretty obvious patterns, learning from feedback that humans provide. And, they also don't get tired after that 8-hour shift, right? You can let it run all night, 24/7, right? And you'll be able to find those patterns and then have them be reviewed by an actual person, right? So one of the exciting things is that, with our experience, right, we found is that, observing these patterns, right, finding, substrings to generate these regexes for, is actually a skill, or, a task that, machine learning is well suited for.
Yeah, and I want to I want to ask you a question there, Mike. What if I'm just really good at writing regex and I can beat the machine? What would you come back at me with?
I think it is possible, but I mean, like, how many hours a day can you beat the machine, right? And I think that's a great point. I think there's also an opportunity too, like, if we look at some of these more advanced models, right? Like, we can say, like, look, Scott is the king of regexes here at Anvilogic, although I shouldn't have said that, because we got some logicians on the call and they might go for your crown, right? But no, it's possible that, like, we can teach the machine, right? So specifically, if you're interested in these things, right, there are effectively translation models, from large language models like T5 Flan, and others, right, where you can say, look, here is the source log, and then this is how, Scott created his regex based on this kind of detection, right? And then you can teach a machine to do better regexes for sure. So I think there's an opportunity to benefit from that. But also, the machine, even if it doesn't write the optimal set of regexes, right, it's going to save a lot of time, period, which I think is probably the benefit for all the humans involved, right? Let the boring and mundane task be outsourced to the silicon. The more interesting, novel challenges of, cybersecurity for the actual, carbon-based life forms. Now, there's one other point I would make about this is, like, you say, Mike, hey, this is pretty cool. You have all this machine learning experience, right? But you're writing out regexes, right? Like, that's not the most exciting thing to do with machine learning, right? Right now with ChatGPT, you can do all sorts of things. Like, I might have today ask GPT to help me organize my day by writing me a schedule, right? That's pretty cool, right? But writing regexes, why is that interesting from a machine learning perspective? So One thing I just kind of want to tie in is this sort of SIMless architecture, right? That we've been, talking about in terms of like, look, we want to leave data where it is, right? It's either with a security vendor or, it's in a data lake, right? And data lake is probably a misnomer. Any of these things like S3, blob storage, right? Databricks, whatever you're using, Snowflake, they're all data oceans effectively. But what's nice is that if you're able to create a regex, right, then basically I can say, look, here's my detection logic. I can push it to the platform where my data resides, and then just say, look, I want to ignore any detections that match this particular logic. So anything from, S3 select, right, Snowflake, Databricks, any other, large, data warehouse, right? You can absolutely express this logic as regexes, and it fits in very nicely. The other thing too is like as we ingest alerts from security vendors, particularly ones that are cloud-based, right? The challenge there is that we could easily just add hundreds of thousands of logs per day based on those vendor alert sources, right? And I think that in that collection phase, right, running a regex is so much more efficient, practical, and simple, right, versus trying to deploy even just a small neural network, right, to do effectively the same thing. So that's where I think like there's a strength that although regexes can be very difficult to write, right, they also have the benefit that I can deploy them, I can leave my data where it is, I can run the regexes against whatever query engine, as well as at collection time for my security vendor alerts, right? I can be able to, filter those streams much more effectively. So the goal really with what we're doing with tuning insights or just really building allow lists or regexes per detection is really tuning the insights, basically our tuning insights shrink the mountain of detections, right? So ideally we're getting to hill-sized amount of detections coming out from each of our searches, right? So ultimately, what the SOC analyst would see is a gentle slope of detections. I'm not going to say like, hey, we can eliminate and only have true positives, right? But ideally, what we can do is reduce it by an order of magnitude. Try to get the number of detections that we would be generating with the raw or untuned rules right down to by 10 or 100 times less, right? So again, I think there's always going to be room for regex. I think that SOC analysts, like as they try to figure out like, okay, where should I start first, right? Again, there are preferences. They may want to even after rules are tuned, we're not precluding them from actually going through and building out their own regexes to kind of search those detections. But we have an opportunity here really to say, look, let's target the the actual rule itself, apply the logic to tune it in the rule itself that the content author can actually review. And then at the end of the day, the SOC analyst isn't responsible for then trying to tune a rule that they may not even know how it works under the hood. So what do you think, Scott? What are your reactions here?
Yeah. One thing I want to add on that is, as you tune more of your detections, then that gives you the opportunity to deploy more varied set of rules. So say you have your existing detections already deployed, they're pretty noisy, you start to tune them. Now you can deploy new detections or maybe, the latest cybersecurity incident, you build a detection for it. Now you have the capacity for your analyst to take a look at those. I think that's a key point. And then once you have a more varied set of rules deployed or detections deployed, then your analysts are looking at, more varied events. It kind of helps fight the alert fatigue. They're not seeing the same thing over and over. It's different things coming in to keep them interested.
Exactly. Right. And I think like that is hopefully the goal, right? Is to keep them on their toes, right? Being able to see, that variety, right? And really be able to expose that. So, the content authors themselves, right? They're not on the hook for then trying to do that ongoing maintenance, right? And of course, invariably there's going to be maintenance with any rule that you deploy as new users come on or you have new telemetry sources. But I think like we can by adopting this approach of saying like, look, on the rule level, what can we do to build out basically regexes so that wherever the data is, I can sort of suppress some number of alerts, is very, is extremely helpful, and it's helping us, be able to provide, better context, more variety, more interesting EOIs on average, right? I think too, it also kind of helpfully changes the game for each, of the, roles in your SOC, right? So, I mean, for the content engineer, I think they'd be more interested, right, in building the new content versus trying to build like try and do this sort of ongoing maintenance where they have to look at thousands of logs to figure out what's the ideal regex, right? At the end of the day, they'll get a few suggestions, and even if they're not perfect, even if they're not optimal, right? It will do a good job of just eliminate, dealing with honestly, content creation fatigue. I'm just creating that word, Scott, right now. I'm going to trademark that phrase. I got to improve on it, but yeah, sort of the content create, content, maintenance fatigue, terrible term. I'm gonna have to work on it. But basically, yeah, that maintenance cost is very high, and it's something that it detracts from the ability to then respond to new threats or really help focus in on areas that are critical for the business, particularly things that maybe your vendor security vendor is not going to focus on. Maybe there are specific threat vectors that are unique to your situation, to your business. So cool. So how do we do it, right? So I would say in general, Scott, keep me honest here, what makes a good allow-less regex, right? Ideally, it matches long human readable substrings in the logs, right? So, I mean, you can have the machine try to come up with the most optimal regex to suppress, true negatives, but if it's incomprehensible, right? It's getting back to that problem that we kind of identified earlier about having, difficult to read regexes, right? And then I think the other thing too is you have to balance it out with, it's extremely unlikely that attack logs will contain those substrings. So I'm thinking like, for example, if you have a regex that matches program files, right? It's probably not the best regex, right? Out there, right? You're gonna probably miss a few things if you just say like, ooh, maybe I'm gonna ignore everything in program data or something like that, right? So it's important that you choose not only like human readable substrings, to form those regexes, right? But also like, you have to have some sense that those regexes like execution policy bypass, right? Would be another, terrible regex to deploy, right? Because it would match not only a lot of good things, but also potentially malicious things. So what's your take on that, Scott?
Yeah, I think you're getting back to some of the earlier slides about reasonably noisy detections and just how it's a balancing act. You're trying to balance the volume of alerts against not missing attacks.
Exactly. So the way that we're doing it here, and I think is exciting, and absolutely like, after this call, we can talk shop, but, extracting the way that we have been looking at is, we look at interesting and most frequently occurring substrings in a set of logs, right? So we just kind of randomly sample these logs using a mixture of ML and heuristics, right? Because it's difficult to teach the machine like all of the experience that you as a security analyst have, right? And it's one of those things that actually is more efficient and more practical in some cases, right? To already come up with a list of things that you don't want, right? In those regexes, period, right? And then allow the ML to kind of fill in the gaps, right? And find those interesting substrings. And absolutely, we also use some heuristics as well to kind of approximate what we think are, long human readable substrings, right? And we also use a greedy approach, right? So basically, we think of this as, in the jargon, kind of like an optimization problem where, what we want to do is take that greedy approach to figure out as quickly, as greedily as possible, what are the regexes that have these sort of commonly occurring patterns, and then keep the ones that are best, and best being matches the most number of logs, right? And that, I think for us, has shown to be pretty good. So does it come up with the best optimal list of regexes every time? No, but the greedy approach, what we've found is that if you look at these regexes, try to figure out which ones match the most number of logs, and then redo the problem with the remaining logs, it seems to eventually converge at a pretty good set of regexes that you can use to suppress a lot of true negatives. So that is our approach. Anything I missed on that, Scott?
Yeah, I got two things there. One, could you explain the greedy approach? I think that's a regex term, is it not?
Oh, greedy approach, absolutely. That not only a regex term, but also I'm thinking here in the algorithmic sense, right? So when you think about solving problems, right, like with dynamic programming and other kind of techniques, right, you have different approaches, right, that will, you can try to exhaustively solve the problem, right? Try to think of every single regex that you could possibly create to match these logs, and then, try to find, but that would be computationally intractable, right? So when it comes to trying to figure out how can I solve this problem in a reasonable amount of time, the nice thing about a greedy approach is you're just kind of making assumptions that if I solve this problem by taking probably what looks like the best solution at this moment, right, in my algorithm versus something like a dynamic programming where you're keeping state, and you can kind of go look back and see, what other solutions that you have and maybe find something more optimal. The greedy approach would say, look, given this set of logs, this regex does a great job of matching the most of them. Let me just repeat this process until I get to a reasonable number of remaining logs, right? And again, that won't necessarily converge at the best set of regexes, but in our experiences, that simple approach of taking what you think is the best regex at the moment and then repeating that process seems to work pretty well.
Awesome. Thanks. Yeah. And then the other thing I wanted to add there was one advantage we have is we see a lot of different companies' logs. So we can, you may bring in a new tool and we've already seen it. So we already have a allow list ready to go. And yeah.
Exactly. And that nicely goes off into this next slide or transitions to this slide. So how do we ease those endpoint log volumes, right? So these are regexes that we use for various rules or searches in our system, right? Across multiple customers, right? So let's take a look at these scheduled tasks, right? So attackers love scheduled tasks, right? To, achieve persistence, right, on a particular machine, but also so does Windows, right? And Windows loves, right, scheduling a lot of tasks for Microsoft Office, right? Here we have click to run and serviceability manager. Another one is we see again, like as you were saying, Scott, like these third-party software solutions like Rivet Networks and then GSS. I can't remember where that's coming from, but these are software that you install on a lot of your endpoints, right? And basically, yeah, like you don't really, the chances of an attack having any of those substrings, period, is extremely low, right? Another one is, when it comes to PowerShell, apparently my favorite topic, right? Splunk Universal Forwarder, right? Creates a lot of PowerShell logs that will trip different IOCs associated with PowerShell, right? But generally speaking, they're really relegated, the universal forwarders, to a really small subset of machines, right? And that the commands themselves have a lot of consistency. So a regex like this will match a lot of the PowerShell invocations that you see for Splunk Universal, any kind of the Splunk software. And then lastly, let's be honest here, like Windows itself is pretty noisy. So this right here is, some log that you see, a regex that matches a lot of logs that has to do with basically, network configurations that, as an analyst, you don't really need to worry about. Right, there's just stuff that happens, is like background radiation, and that you can successfully eliminate those logs as you're looking for other CMD type execution. So that's what we're doing on the endpoint. And then how do we make cloud logs less torrential, right? Because I think that what we've seen with our customers is that anytime you have a cloud-based third-party integration, right, the SOCs are going to be inundated with alerts. And the reason probably for that is because of misconfiguration. So whoever set up the tool, all of a sudden you get all of these either API calls or API errors, right? And the thing is that, well, the tool works, so no one's going to go out and necessarily go fix it, right? Just because it's very difficult to do that. And you don't want to, by virtue of fixing a misconfiguration, cause another issue. But also sometimes, people like, in the security, roles don't have that kind of control to really make those changes unilaterally. And it could take some time to really, iron out all these misconfiguration bugs, right? So what we found is that if we look at these sort of Lacework, Datadog, Prisma Cloud, as we look at a lot of the, alerts that come out of those specific tools, right? What we find is that it's useful to match on more than one field, right? And we find for like Datadog deployments, there's a lot of misconfiguration when it comes to CloudWatch API errors. And that we find is that the role that generates those errors looks like Datadog integration role, right? So a very simple regex can then eliminate a lot of alerts in your alert lake. So the other one too is with Prisma Cloud. Prisma Cloud makes a lot of API calls like describe connections, which are just again, if you have malware in your cloud environment, like absolutely, they're probably going to be calling describe connections, try to understand, do some reconnaissance, right? To figure out like in discovery commands to figure out like, where am I? What kind of permissions do I have, right? But if you see a role matching Prisma Cloud root org member slash Redlock, right, I wouldn't be as concerned about that. And this is probably something that you can kind of safely ignore, at least on a first pass. So yeah, those are kind of things. So any thoughts on that, Scott?
Yeah, just one. So one thing you kind of mentioned or hinted at, the cloud typically comes with lots of logging enabled, which is great. You have lots of visibility, but flip side is super verbose, and that's where the tuning insights and tuning your detections can be super critical.
Exactly, exactly. Particularly if you let them in, like basically if you, have, these deployments and you're trying to look at each of these one by one, it's going to be very difficult. So
Yeah, I mean, just as we've gone through today, you have challenging problem with creating detections and maintaining them, even more so than just creating them. And that's really the balancing act, the challenge, et cetera, that we've been talking about is how do you keep good visibility in your logs, but not overwhelm your analysts, not run into alert fatigue, have them, just seeing 1,000 of the same alert, and then, the 1,001 alert is the actual interesting thing, and they're, tired of looking at it. Yeah, that's what I got.
no, I like that a lot, right, Scott? Like I think like the big thing is, humans have great ability. Like here, I know I'm the ML guy. I love doing all like making all this AI to do this, that, and the other thing. But I think like really when you have those thousands of alerts that look pretty similar, like that is really well within the wheelhouse, right, of machine learning, AI, data science, right, to basically say, look, how can we reduce that? How can we summarize it? So that really what you can do is have your analysts really focus on the most tricky, most difficult, problems, which is trying to make heads or tails of really just like really unique, really extraordinary kind of like PowerShell snippets that you might see, or just really interesting log commands or unusual connections you've never seen before. So that's really where you want your people power focused on, and not really on the same alert triggering day in, day out, 7 days a week. So yeah, I think that's again a great application of machine learning to a problem to help make your SOC more efficient.